Diffusion models turn random noise into photorealistic images. They power Stable Diffusion, DALL-E, Midjourney, and most text-to-image tools you have used. The trick is to pair two processes. The forward process takes a real image and adds noise to it a little at a time until nothing but static remains. The reverse process is a neural network trained to undo that corruption, one step at a time. Generate by starting from noise and running the reverse. Here is what the forward chain looks like. 7 steps from a clean image on the left to pure noise on the right. Each tile is slightly noisier than the one before it. Mathematically, the forward step is a Gaussian. The mean shrinks by square root of 1 minus beta, and the variance is beta times the identity. Because each step is Gaussian, we can skip ahead. Getting x at any time t directly from x_0 only requires the cumulative product alpha bar. The reverse process walks the same tiles, right to left. Starting from pure noise, the network predicts a slightly cleaner image, step by step, until it hands back a fresh sample. The elegant part: instead of predicting the clean image, the network predicts the noise that was added. The loss is a simple L2 between the true noise epsilon and the network's guess. Training is just gradient descent on millions of noise-level samples. To generate, start with a random tensor of pure noise and apply the reverse step t times. Each step subtracts the predicted noise, then adds a little fresh randomness to keep the trajectory exploratory. After about 50 to 1,000 steps, you get a clean image. The denoiser is almost always a U-net. Downsampling blocks compress the image, and attention bottleneck ties everything together. Upsampling blocks then rebuild the image, with skip connections shown dashed, carrying fine detail across the bridge. To control what gets generated, the U-net accepts an extra signal. A text prompt runs through an encoder like clip, becomes a 768-dimensional embedding, and steers every denoising step via cross-attention. Classifier-free guidance runs the U-net twice, once with a prompt and once without, and amplifies the difference to lock the output onto the text. High-resolution images are expensive to diffuse. Latent diffusion solves it by compressing first. A variational autoencoder turns the image into a latent 8 times smaller. Diffusion happens in that compact space, and the decoder projects the result back to pixels. That's the idea behind Stable Diffusion. The same math powers Stable Diffusion, DALL-E, and Midjourney. Most open-source image generators you run locally are diffusion models built on these exact principles. From one idea, learn to denoise, an entire creative industry.